For most of human history, the universe appeared simple from a distance. Ancient civilizations looked into the night sky and saw scattered stars shining against darkness. Later, telescopes revealed planets, nebulae, and distant galaxies. But even as astronomy advanced, one assumption remained deeply rooted in human understanding: the universe looked random. Galaxies appeared like isolated islands drifting through endless emptiness. But modern cosmology has slowly revealed something far stranger. The visible universe may only be the surface of a much larger hidden structure, an invisible framework shaping everything from galaxies to the expansion of space itself. And now, a powerful new observatory is beginning to reveal that hidden architecture in extraordinary detail. Its name is Euclid. Unlike traditional telescopes designed primarily to observe individual stars or planets, Euclid was created with a completely different mission. It was built to study the universe on its largest possible scales. Its goal is not simply to photograph space. Its goal is to map reality itself. Positioned nearly 1.5 million kilometers from Earth at the Sun-Earth L2 point, Euclid quietly surveys enormous regions of the sky. Over the coming years, it will observe billions of galaxies spread across more than one-third of the visible universe. The result will become one of the most detailed three-dimensional maps ever created. But Euclid's true power lies not only in what it sees directly. It lies in what it reveals indirectly. For decades, scientists have known that visible matter alone cannot explain the structure of the cosmos. Galaxies rotate too quickly. Galaxy clusters contain far more gravity than visible material can account for. Something unseen appears to dominate the universe. This mysterious substance is known as dark matter. Dark matter does not emit light. It cannot be observed directly through ordinary telescopes. Yet its gravitational influence shapes galaxies and bends space itself. Euclid was specifically designed to trace those invisible effects. One of its most important tools is a phenomenon predicted by Albert Einstein in the theory of general relativity, gravitational lensing. According to Einstein's equations, massive objects warp the fabric of spacetime. As light travels through these warped regions, its path bends slightly. When light from distant galaxies crosses billions of light-years of space, hidden concentrations of dark matter subtly distort those images. The distortions are incredibly tiny. A galaxy may appear stretched by only a fraction of a percent. Individually, these changes are almost impossible to detect. But when millions of galaxies are analyzed together, patterns begin to emerge. Those patterns reveal where invisible matter exists. In effect, Euclid is not simply photographing galaxies. It is creating maps of the unseen universe. As the telescope released its first major observations, astronomers immediately recognized the importance of what they were seeing. The images were staggering in scale. Each survey combined hundreds of exposures containing millions of galaxies inside a single region of sky. Tiny points of light filled every direction. Some galaxies appeared close and bright. Others were so distant their light began traveling toward Earth before the Sun even existed. Yet the most remarkable discovery was not the galaxies themselves. It was the structure connecting them. Instead of appearing randomly scattered, galaxies formed enormous interconnected filaments stretching across space like glowing rivers. Dense galaxy clusters appeared at the intersections, while enormous voids separated these regions across unimaginable distances. The universe suddenly looked less like chaos and more like a vast cosmic network. This structure is known as the cosmic web. For years, simulations predicted that gravity slowly organized matter into giant filaments after the Big Bang. Computer models showed how dark matter could pull ordinary matter together, eventually forming galaxies and clusters along invisible pathways. But simulations are one thing. Seeing the structure emerge in real observations is something entirely different. Euclid is now revealing those patterns directly. Some of these structures extend across hundreds of millions of light years. Their scale is so enormous that human intuition struggles to fully grasp them. Entire galaxies become tiny components within larger systems. Some scientists compare the cosmic web to neural networks inside the brain. Others compare it to roots spreading beneath forests or fibers woven into fabric. These comparisons are only metaphors, but they reflect an important truth. The universe appears deeply interconnected. One early study focused on the Perseus cluster, one of the largest known structures in the nearby universe. At first glance, Perseus appeared familiar. Previous telescopes had studied it for decades. But Euclid revealed astonishing new detail hidden inside the region. More than 100,000 faint background galaxies emerged from the observations. Hundreds of dwarf galaxies also became visible, tiny systems that act as sensitive tracers of dark matter behavior. And what scientists observed raised new questions. Instead of smooth distributions, dark matter in some regions appeared uneven and clumped in unexpected ways. These findings may eventually help scientists refine existing models of cosmic evolution. Euclid also uncovered hidden structures in regions much closer to Earth. In areas like the Horsehead Nebula, the telescope revealed faint stars hidden behind clouds of dust and gas. Some observations even hinted at isolated planetary mass objects drifting freely through space without stars. These wandering worlds may have been ejected from ancient planetary systems billions of years ago. Or they may represent entirely new classes of celestial objects still poorly understood. Even familiar regions of the cosmos continue to contain hidden complexity. And perhaps the most remarkable fact is that Euclid has only begun its mission. Most of its survey remains incomplete. Most of its discoveries are still waiting inside enormous streams of data not yet fully analyzed. But already, the telescope is transforming humanity's understanding of the universe. Not as scattered islands in darkness, but as a deeply connected structure shaped by invisible forces across cosmic time. As Euclid continues scanning the cosmos, one conclusion becomes increasingly unavoidable: most of reality is hidden. Everything humanity normally sees, stars, planets, galaxies, gas clouds, oceans, mountains, and living beings, represents only a small fraction of the universe. Ordinary matter makes up only a tiny percentage of cosmic existence. The rest consists primarily of dark matter and dark energy, mysterious components that remain among the greatest unsolved problems in modern science. Dark matter acts like invisible scaffolding holding galaxies together. Dark energy appears to drive the accelerating expansion of the universe itself. Together, they dominate cosmic evolution. Yet neither can be directly observed. This is what makes Euclid so important. Rather than searching only for visible objects, the telescope studies how invisible forces shape the structure of space over billions of years. One of Euclid's greatest strengths is its ability to observe the past. Because light travels at a finite speed, distant galaxies appear not as they exist today, but as they existed billions of years ago. A galaxy located 10 billion light-years away is seen as it looked 10 billion years in the past. This means Euclid is effectively observing different eras of cosmic history simultaneously. Nearby galaxies represent the modern universe. Extremely distant galaxies reveal the early universe shortly after the Big Bang. Together, these observations allow scientists to reconstruct a timeline of cosmic evolution. Astronomers can study how galaxies formed, how matter clustered together, and how large-scale structures changed over billions of years. And early results are already producing intriguing mysteries. Some galaxies in the young universe appear more developed than expected. Certain structures seem to have formed surprisingly quickly after the Big Bang. According to some cosmological models, the early universe should have remained relatively smooth for longer periods before large structures emerged. But Euclid's observations suggest matter may have organized faster than anticipated. These findings do not destroy current cosmology, but they create tension between prediction and observation. And throughout scientific history, such tension has often led to major breakthroughs. The discovery of cosmic expansion began this way. So did dark matter. So did dark energy. Unexpected observations force scientists to refine theories and sometimes completely rethink assumptions about reality. Euclid may now be contributing to another such transformation. Another area of growing interest involves the enormous cosmic voids between galactic filaments. At first glance, these regions appear almost empty. But Euclid is showing that even emptiness contains structure. The shapes and expansion patterns of these voids are influenced by gravity and dark energy. By studying them carefully, scientists hope to better understand why the expansion of the universe is accelerating. In other words, empty space itself may contain clues about the fate of the cosmos. Perhaps one of the most extraordinary aspects of the mission is the sheer scale of its data. Euclid observes millions upon millions of galaxies. Each must be identified, measured, classified, and analyzed. The amount of information is so enormous that human scientists alone cannot process it efficiently. As a result, artificial intelligence systems have become essential tools in modern astronomy. Machine learning algorithms help detect lensing distortions, classify galaxy shapes, identify hidden structures, and discover patterns invisible to direct human observation. Humanity is now building intelligent systems to help understand a universe too vast for unaided human comprehension. This partnership between astronomy and artificial intelligence may become one of the defining scientific developments of the century. Because the deeper humanity looks into space, the more complex reality appears. The old vision of isolated galaxies floating through empty darkness is fading away. In its place emerges something far more intricate. The universe resembles a gigantic interconnected network stretching across unimaginable distances. Invisible rivers of dark matter guide the formation of galaxies. Massive clusters form gravitational intersections within the cosmic web. Vast voids expand between them like enormous cosmic oceans. Everything appears connected through hidden structure. And perhaps the most profound realization is this: what humanity sees may represent only the thin visible layer of a much larger reality. Stars and galaxies may simply illuminate an invisible framework extending across the entire observable universe. Euclid is not solving every mystery, but it is revealing the outlines of something extraordinary. A cosmos woven together by forces still not fully understood. A universe shaped by hidden architecture beneath the visible world. And somewhere inside that immense cosmic web, humanity continues searching for meaning, understanding, and its place among the stars.